Welcome to lesson 6.4, solving equations using algebra. And in this lesson, our focus is on solving problems by finding the equations and solving them algebraically. So this whole unit 6 that we've been working on is different strategies to solve algebraic equations. And you've learned how to do it more visually or pictorially using algebra tiles or balancing scales. And now it's time to start moving away and kind of thinking a little bit more abstractly. So solving an equation using algebra is often the quickest way to find a solution, especially when we're dealing with larger numbers and larger equations that we can't use mental math for, that we can't do in our head. So just a refresher, if you recall that when we solve an equation in algebra, we're looking for the value of the variable for the equation to be true. So just for example, if we take the equation, 2n plus 3 equals 11, what we're trying to look for is what value is our variable. What does n have to equal in order for this equation to be true? And then when we find what the value of n is, when we substitute it back into the equation, that would mean that the left side of our equation here would equal the right side of the equation. So when we solve an equation using algebra, remember the balanced scales model just in the back of your mind, and that idea of preservation of equality, meaning whatever you do to one side of the equation, you always do to the other side of the equation, because you're preserving the equality, you're keeping both sides of the equation equal. So I've put an example up here that's right from the textbook. I'm looking on page 237 and 238, and we're just going to go through an example together of how this might look to solve an equation using algebra. So our question says 3 more than 2 times the number is 27. So I'm just going to use my pencil here, and I'm just going to underline the important parts of the equation. So 3 more than 2 times the number is 27. So my first step is A, to write an equation to represent the problem. Then we're going to solve it, and we're going to show all of our work. And then, of course, as always, we're going to verify our solution just to make sure we're correct. So when I read this, what do each of these underlined parts represent? 3 more, because I see the word more, I know we're talking about addition. 2 times a number. So I know that's going to be 2 multiplied by our variable, because we don't know what our number is. And then on the right side of the equation is 27. I know that is kind of another word for equals. So what that would look like in terms of an equation for part A, 3 more than 2 times a number equals 27. So when I read this, you could also write it as 3 added to 2n equals 27. Doesn't make much difference when we're using adding, but for my sake, I'm going to use the first example. So 3 more than 2 times the number equals 27. So when I look at this, I think to myself, okay, I want to figure out what does n equal? What does my variable equal in order for this equation to be true? And so what I want to do is I want to try to isolate the variable. And isolate the variable just means you need to try to get the variable by itself so I can see what n equals. Because right now I know that 2n plus 3 equals 27, but I just want to know, what does n equal? So looking at this right away, I see that I have this positive 3. And that's kind of standing in my way of me figuring out what n is. So I want to essentially make this 0. And when we think back to previous lessons where we've used algebra tiles, how do we do that? We did that with algebra tiles by making 0 pairs. So essentially I'm going to do the same thing, but without actually drawing out algebra tiles. So if I have positive 3, what do I have to add to that to make that equal 0? Just imagine me using algebra tiles and trying to make a 0 pair. So I'm going to add, or I'm going to subtract, I guess, 3. Because I know that positive 3 subtract 3, that equals 0. So essentially, I've just made this part of my equation 0. However, in order to preserve equality of our equation, what you do to one side of the equation, you always do to the other side of the equation. So because I've subtracted 3 from the left side, I have to subtract 3 from the right side. So I'm going to rewrite out my equation now, which equals 2n. This is still remaining. This now becomes 0, so we don't need to include anything. Equals 27 subtract 3 is 24. So now we still need to take it one step further because I still don't quite know what n equals. I know that 2n now equals 24, but what does just my n alone equal? So when I look on the left side of the equation, I see that we have 2n here and that we have 24. And so I need to try to get n by itself, but I have this 2. How do I make, and if we recall, this represents multiplication, 2 multiplied by n. How do I make that 2 equal 1? I just want to know what 1n equals. I need to divide by 2 because we know that 2 divided by 2 equals 1. And again, what we do to the left-hand side of the equation, we do to the right-hand side of the equation. So 24 divided by 2. And then if I rewrite this out one last time, I know that 2 divided by 2 is n. Whoops. So I only have n left on this side. I could write 1n, but that's not really necessary. So n now equals, what is 24 divided by 2? We know that's 12. So I've now just solved what my variable is. So n in this instance equals 12. But we're going to go put that back into our equation to address part C of our question and to verify our solution. So let's go back up and rewrite our equation. This was our original equation here, 2n plus 3 equals 27. I've solved that n equals 12, so I'm just going to plop 12 into the equation where n is. So 2 multiplied by 12 added to 3. And then we're going to see if this equals 27. And if it does, then we know that our answer is correct. So 2 multiplied by 12 I know is 24. And then I know that 24 added to 3 is 27. So we were indeed correct with our answer there. And so just one last reminder before you get working on the practice questions for this section is that it's really important not only to solve the equation, but to verify your solution. Because you might have made a little mistake or, miscalculated somewhere. That happens, and you'll be able to catch your mistakes and fix them more easily and see where you went wrong if you're taking that next step in verifying your solution. So again, it's not just solving it, and it's taking that next step and making sure that you were actually correct in solving it. And just before we wrap up, I'm going to do one more really quick example and just walk through one more example together just to make sure you really have a solid idea of this concept. So I'm just going to write up an equation. Let's do 3x subtract 4 equals 11. So now I have my equation written out for me, and I want to solve what does x equal in this equation. So I see that I have this -4 here, and that's kind of my first step is to make that equal 0 so I can get one step closer to figuring out what my x equals. So I see that it's a -4, so in order to make that essentially equal 0, I have to add 4 on it. So I'm basically making 0 pairs without actually drawing it out. Because I know that when I combine -4 and +4, that's going to equal 0. I'm just adding the opposite pair. And what I do to one side of the equation, I always have to do to the other side of the equation, so I'm going to add 4 there. When I redraw out what my equation looks like, I'm left with 3x, remember that equals 0, equals 11 added to 4 is 15. So now I know that 3x equals 15. But I don't want to know what 3x equals, I want to know what x equals. So back on my left-hand side of the equation, I want to make my x equal 1 because I want to know what 1x equals. But I have the 3 there, so I need to divide by 3. And what I do to one side of the equation, I do to the other side of the equation. So when I rewrite this out again, I know that 3 divided by 3 equals 1, so I'm just left with 1x equals 15 divided by 3 equals 5. And so just to double check my answer, I'm going to put it right back up into my initial equation just to make sure that I followed all the steps and I didn't make a mistake somewhere. So if I just insert 5 into where my x was in my original equation, we're going to just make sure that it equals 11. So I know that 3 times 5 is 15. Subtract 4 equals 11. So I was correct in following my steps.